Testing principles serve as foundational guidelines and best practices that shape the testing process throughout the software development lifecycle. These principles provide a framework for testers to conduct testing activities systematically and effectively. In this section, we will explore the fundamental principles of software testing and their significance in ensuring the quality and reliability of software products. Testing principles play a pivotal role in shaping the testing strategies, methodologies, and processes used in software development. They provide a set of guiding concepts and best practices that help testers conduct testing activities effectively and efficiently. Adhering to testing principles ensures that testing efforts are focused, systematic, and aligned with project objectives. By following these principles, organizations can enhance the effectiveness, reliability, and quality of their testing processes, ultimately leading to the delivery of high-quality software products that meet user expectations. The International Software Testing Qualifications Board, ISTQB, defines 7 fundamental principles of software testing. These principles serve as guiding concepts for testers and organizations to conduct testing activities effectively. 1. Testing shows the presence of defects. Testing aims to uncover defects or errors in the software, providing information about the presence of defects rather than proving their absence. 2. Exhaustive testing is impossible. It is impractical to test every possible input combination or scenario within a software system. Therefore, testing efforts should focus on identifying critical test cases and scenarios that have the highest likelihood of uncovering defects. 3. Early testing. Testing should be conducted as early as possible in the software development lifecycle to identify and address defects when they are less costly to fix. 4. Defect clustering. A small number of modules or components often contain the majority of defects. By identifying and focusing testing efforts on these defect-prone areas, testers can maximize the effectiveness of their testing activities. 5. Pesticide paradox. Repeatedly executing the same set of tests may overlook new defects or vulnerabilities. Testers should periodically review and update their testing approach to ensure its effectiveness over time. 6. Testing is context-dependent. Testing practices and techniques are influenced by the specific context of each project, including project requirements, constraints, and objectives. Testers should adapt their testing approach accordingly to maximize its effectiveness. 7. Absence of errors fallacy. The absence of detected defects does not imply the absence of defects altogether. Testing can only provide information about the presence of defects, not their absence. Therefore, testers should remain vigilant and continue testing even when no defects have been identified. This principle underscores the essence of testing in software development. Testing aims to uncover defects or errors in the software, providing valuable insight into the quality of the product. However, it's important to note that testing cannot guarantee the absence of defects. Instead, it reveals the presence of defects, enabling testers to identify areas for improvement and make informed decisions about the software's readiness for release. By embracing this principle, organizations can prioritize testing efforts and allocate resources effectively to ensure the delivery of high-quality software products. This principle highlights the practical limitations of testing. In software development, it's virtually impossible to test every possible combination of inputs, scenarios, and conditions. The number of potential test cases grows exponentially with the complexity of the software, making exhaustive testing impractical and unfeasible. Instead, testers focus on identifying critical test cases that have the highest likelihood of uncovering defects. By prioritizing testing efforts and strategically selecting test cases, organizations can maximize testing efficiency and effectiveness while managing resources wisely. This principle emphasizes the importance of conducting testing as early as possible in the software development lifecycle. By initiating testing activities early, defects can be identified and addressed when they are less costly to fix. Early testing helps prevent defects from propagating to later stages of development, where they can become more complex and expensive to resolve. Additionally, early testing enables organizations to validate requirements, clarify expectations, and ensure alignment with project objectives from the outset. Embracing early testing practices empowers teams to deliver higher quality software products while minimizing risks and accelerating time to market. Defect clustering is a phenomenon observed in software development where a small number of modules or components contain the majority of defects. This principle highlights the importance of focusing testing efforts on these defect-prone areas to maximize the effectiveness of testing activities. By identifying and prioritizing testing for these high-risk areas, testers can uncover a significant number of defects and allocate resources efficiently. Defect clustering underscores the need for targeted testing strategies that address the areas most likely to contain defects, ultimately enhancing the overall quality and reliability of the software product. The pesticide paradox highlights the need for testers to periodically review and update their testing strategies. Just as insects can develop resistance to pesticides over time, repeated execution of the same set of tests can lead to the overlooking of new defects or vulnerabilities. Therefore, testers must regularly reassess their testing approach and introduce new test cases to ensure comprehensive coverage. By embracing this principle, organizations can adapt to evolving software requirements and technologies, maintaining the effectiveness of their testing efforts over time. This principle emphasizes that testing practices and techniques are influenced by the specific context of each project. Factors such as project requirements, constraints, objectives, and the development environment can significantly impact testing approaches. Therefore, testers must adapt their testing strategies to suit the unique context of each project. What works well for one project may not be suitable for another. By considering the context of the project, testers can tailor their testing efforts to maximize effectiveness and efficiency, ultimately contributing to the success of the software development endeavor. The absence of errors fallacy is the misconception that the absence of detected defects implies the absence of defects altogether. However, testing can only provide information about the presence of defects, not their absence. Even if no defects are identified during testing, it does not guarantee that the software is defect-free. Therefore, testers must remain vigilant and continue testing rigorously, even when no defects have been found. By recognizing and addressing this fallacy, organizations can maintain a proactive approach to testing and ensure the reliability and quality of their software products. In conclusion, the 7 principles of software testing provide essential guidelines for effective and efficient testing practices throughout the software development lifecycle. By understanding and applying these principles, organizations can enhance the quality, reliability, and effectiveness of their testing efforts. Testing shows the presence of defects, but exhaustive testing is impossible. Early testing helps identify and address defects when they are less costly to fix. Defect clustering highlights the importance of targeting testing efforts on defect-prone areas. The pesticide paradox reminds us to update testing strategies regularly. Testing is context-dependent, requiring adaptation to the specific project context. Finally, the absence of errors fallacy cautions against assuming that the absence of detected defects implies the absence of defects altogether. By embracing these principles, organizations can optimize their testing processes, minimize risks, and deliver high-quality software products that meet user expectations and business objectives.